In this video, we will talk about level curves. So let's begin by defining it, and then we'll get into some examples. So a level curve of a function f of x comma y is a graph of f of x comma y equals c, where c is a constant. So we're taking our function of two variables, and we're setting it equal to some number, some constant number. And when we do that, we get an equation with two variables in it. So its graph is going to be in the xy plane. All right, so let's look at an example. Okay, so not there. All right, so here is the first example that I want to look at. So let's draw the level curves of f of x comma y equals x squared plus y squared for c equals -1, 0, 1, and 2. All right, so what I need to do is I need to find the level curve for each of these values. So let's start with c equals -1. So once I have my c value, I set my function's formula equal to it. So we're going to set x squared plus y squared equal to -1. And that equation has no solution. No solution since x squared plus y squared, well, when you square something like x squared, we'll get a non-negative number. This is always greater than or equal to 0. So x squared is greater than or equal to 0. Y squared is also going to be greater than or equal to 0. So when you add two things that are non-negative together, we get something that is greater than or equal to 0. So there's no way it's going to be equal to -1. All right, so let's look at the level curve when c equals 0. So when c equals 0, we set our formula for our function, x squared plus y squared, equal to 0 now. So this is actually going to give us something. This gives us, well, the x equals 0 and y equals 0. And that graph is going to be a point. Okay, so I'm going to start to draw a graph of these. So I'm going to let me scroll down a little bit more. A y-axis and an x-axis. So y-axis and an x-axis. So when c equals -1, there's nothing to draw because my equation has no solution. When c equals 0, there is something to draw. I get x equals 0, y equals 0. So that is a point right at the origin. That's my level curve when c equals 0. It's actually just a single point. All right, so next let's do c equals 1. So setting c equal to 1, I set my function x squared plus y squared equal to 1. And that's, what is this graph shape? Well, that's a circle. That is a circle. And the center of that circle is at the origin, and the radius is 1. So we'd go up height of 1 in every direction 1 from the origin. So I draw in this circle of radius 1. Okay, and that's the level curve for when c equals 1. If I do c equals 2, we get x squared plus y squared equals 2. So we're setting our formula, x squared plus y squared equal to 2. And this is another circle. This is another circle. Same center, origin. The radius is just a little bit bigger. This radius is square root of 2. Okay, so square root of 2 is about 1.4. Okay, so square root of 2 is just a little bit above where 1 is. So square root of 2. So if I draw in that circle, I get something like this. Coming around, finish that circle. And that's where we are when c equals 2. Okay, so we've drawn the level curves that this asked for. Let's just draw one more for practice. If I set c equal to 3, I'd get x squared plus y squared equals 3. And that's going to be another circle, slightly larger in this one, but it's not quite as far out as the step that I took from the c equals 1 curve to the c equals 2 curve. To get to c equals 3, I don't go quite as far out. So the distance between my circles is not as big here. So this purple curve that I'm drawing is closer to the green one, where c equals 2, than the distance between c equals 1 and c equals 2. Okay, so this is where we are when c equals 3. So we have these level curves. So graphically, one of the ways I can think about these level curves is, this is the cross section where the graph intersects the plane z equals 2. Okay, and that's one of the big reasons why we talked about cross-sections way back when we talked about graphing 3D surfaces. It's because they were going to show up again later when we talked about level curves here in, now that we're talking about multivariable functions. Okay, so one of the things that we can do with these level curves is we can use the level curves to either try to draw or describe our graph. So we can use these to either draw or describe our graph. All right, so if I draw in a 3D graph now, so I'll have my axes, z and x and y, and I'll draw negative direction, so negative z direction, negative x direction, negative y direction. If I draw in these level curves, what the c value tells me is the height. So c tells me the height. It's telling me the z coordinate. Okay, so when c equals 0, that means z is 0. So when z equals 0, the cross-section is just a single point. And it happens to be when x and y are 0, so it's at the origin. Okay, and then when c is 1, that means now we're at a height of 1. Z is 1. And our cross-section is a circle. So we're going to get a circle. I'm going to try to draw a circle. And in the back, I won't be able to see, so I'll draw a dash line. And then when c equals 2, so that's when it was 1. When it was 2, now I'm at a height of 2. I get a larger circle. Slightly larger, but larger nonetheless. So I'll draw a larger circle. In the back, I won't be able to see anymore. Okay, and as we do this, we keep getting larger and larger circles the further out we go. But for each increase in unit, upwards, if I keep increasing the height by 1, the circles each time they get bigger by a smaller and smaller amount. So I start to get this kind of shape. It starts to curve inwards because as I go higher and higher up, the circles, how much they get bigger by from unit to unit, gets smaller and smaller. So I get a shape like this, which is what we would expect because we graphed this thing in the last video, and now at this point we're pretty comfortable with drawing these paraboloids. Okay, so we can use our level curves to draw or describe the shape of our graph. So level curves, another way to think about them is they are like contour maps. Or sometimes these are called topographical maps. So if you've hiked before or done something like outdoors before with a topographical map, or in other words, a contour map, these are often used to describe things like mountains, and they're guides for climbers to know which direction is steeper, which direction is flatter, so they can plan their climbs, for example. Okay, so a couple comments about these contour maps. So thinking about it this way, the points on the same curve, the same level curve, have the same height. So for example, all the points on this blue curve here, so the blue curve corresponded to c equals 1, every single point on this blue circle has a height of 1. And I saw that in the 3D picture. All of these points on the blue circle all had a height of 1. They were 1 unit above the xy plane. Second key observation is the closer the level curves are, the steeper the graph is. Because that means my graph is changing in height more quickly. By me traveling a shorter distance, it's increasing the same height. So if I look at this picture, the curves from when c equals 2 to c equals 3 are closer together than the curves from when c equals 1 to c equals 2. And graphically that's playing out because the further out I get along this paraboloid, the steeper it gets. Okay, so that's another thing that I can take away from those level curves. Closer they are together, the steeper the actual 3D graph is going to be. All right, so let's look at another example. So let's do a more complicated level curve, an example where I try to use the level curves to draw the 3D picture. So this graph contains some level curves, and I want to draw a rough sketch of the corresponding 3D surface. Okay, so I have this, this one looks more like a contour map if you've seen contour maps. But I have some level curves, so there's a couple of level curves here that correspond to a height of 800, and then the other level curves kind of go down at increments of 50. So there's one at 750 on both sides, sort of here. One at 700, the orange one at 650, and this outer one is at 600. So what I'd like you to do is to first pause the video for about 30 seconds and see if you can think about what this graph will look like when I draw it in 3D. Just can you describe the shape of this? 4, 3, 2, 1. Pause the video. Pause the video and try this for about 30 seconds. See if you can think about what the graph shape will look like. All right, so hopefully you've done that. Hopefully you've paused the video to try that and think about it. So this graph, so the fact that I have these two regions, these two circles that correspond to a height of 800 makes me think that there's sort of like two peaks here. This is a mountain. I can think of this as a mountain with two peaks. And the two peaks have about the same height, because I see that the height of those sort of inner circles is 800, at least around these, the curved part of it. Inside that curved part, it might get a little bit higher. Okay, but the two peaks have about the same height, and moreover, the peaks are both on the x-axis. Okay, so if you're a Bay Area local, for example, this might remind you of Twin Peaks in San Francisco. Okay, and that's actually where this graph is motivated from Twin Peaks. Okay, so now let's try to draw a rough sketch in 3D. So I'll draw a z-axis, an x-axis, and a y-axis. Let's draw some negative directions, so negative z, negative y, negative x. Okay, so let me just draw dots for the peaks of these in the level curve. So maybe the peak of this one on the left is somewhere here. I don't know, I'm just speculating. Maybe the one on the right, maybe the peak is just somewhere there. Again, I'm just kind of guessing a little bit because it just said to draw a rough sketch. So I know those peaks are somewhere on the x-axis. So this one on the right is on the positive x-axis. So if I were to draw that one, I'd pick some point on the positive x-axis, go up for a bit, and maybe let's say this is the peak of that one. And then for the other one, for this other one, I pick a point on the negative x-axis, go up from it, about the same distance, and then there's the peak. Now let's draw in some of these level curves. Okay, so I'm going to begin by drawing in these level curves at a height of 800. So there's one around the circle, there's one around the peak that's on the negative x-axis. So I have to go down a little bit from that height, just a little bit, maybe not even that far, maybe like this far. And then I draw in this circular, maybe ovalish shape to kind of represent, oh, that's how high it would be around there. Okay, and I'm drawing a dashed line at the back because I might not be able to see that. So same thing at the other peak. I go down a little bit once I reach that height of 800. So that's this circle right here. This is on the positive x-axis side. And that circle is a little bit smaller than the one that I drew on the negative x-axis side. So I'm going to draw a circle here, but this one's going to be a little bit smaller. On the back side, I may not be able to see, so I draw a dashed line. Okay, I'm going to skip the blue level curve, and I'm going to go to the green one. So the green one is 100 units down. So 100 units down, maybe that's somewhere down here. And on the other side, maybe somewhere down here. So on the positive side, I'm going to draw in this green curve. So I'll just draw a rough picture. Some circular ish shape. Okay, so that's this green curve. And on the negative side, I have another circle as well, but a little bit bigger than the one on the positive side. Okay, so I'm going to draw the circle. Doesn't have to be perfect. Could be a little bit oblong. It's not a perfect circle, even in the level curve. Awesome. All right, next let's draw this orange curve. So the orange one looks a little bit weird. I have to go down, this time 50 units to get from 700 to 650. So I don't go down quite as far. let's say I go down this much, and this much, and this curve is a little bit different. You know, I'll still kind of wrap around this curve right here, but what happens is as I get here, it's sort of like, it does this thing where it sort of crosses over itself. So I'm going to draw a line kind of going to the other side here, and then it would sort of loop around the back side of this peak, so I won't be able to see it anymore. I'm drawing a dashed line, and then I will be able to see it again. So it'll come around the front. It crosses here. Here's that crossing point, and then it'll go this way, and then I might not be able to see it on the back side. Back side. All right, and then the front part will loop around and connect with that. All right, let's also draw this level curve at 600. So at 600, that's a little bit down, another 50 units down. All right, so I'm going to draw what starts off as a slightly larger thing around. But when I get to this point, it doesn't come and cross. It does one of these, kind of matching what's going on with the level curves here. There's one of these that kind of goes around. Then at some point it'll go behind. I won't be able to see it anymore. It's going behind. I can't see it. I can't see it. I can't see it. And then at some point, yeah, maybe I will be able to see it because I'm looking at it from above. And then it does this. And then it kind of goes behind again. Kind of goes behind. And then maybe again I start to, maybe somewhere over here, I start to see it again. And I have something like this. All right, so now let's make this look a little bit more 3D and a little bit more mountain-esque. Okay, so where these circles or these oval type shapes are at a height of 800, realistically mountains are probably, at the top, typically they have plateaus. In my level curve map, the height within this circle didn't change that much. Like I didn't see it jump from 800 to 900, like a drastic spike. So I'm thinking maybe once I get from the 800 part to the top, maybe it's, flattish, kind of, plateauish. I'm going to draw a plateauish thing on the other side as well. And if I didn't draw a plateau, if I made it sharp, that's okay. This problem just had to draw a rough sketch. And then I'll draw some lines kind of going down the sides. So line this way going down the side, and maybe this way going down the side, and this way going down the side. And let's do that for this back peak as well. This way down the side, and this way down the side, and the back way down the side. And then for this front peak, let me also draw a line going backwards this way, and then to this point where the orange curve sort of crosses itself, and then climbing up this other peak that way. So I can see from this picture that this point where the orange level curve sort of crossed over themselves, that is a saddle point. That's the saddle of this mountain. One of the ways I can tell that's a saddle from the level curve is if I look at that crossing point where the orange crosses itself, if I were to go right in the positive x direction or left in the negative x direction, my height increases. I go up in height because I'm going towards a height of 700 and then 750 and then 800. But if I were to go in the y direction, up in the positive y direction or down in the negative y direction, my height decreases from a height of 650 down to 600. And that's the kind of thing that creates a saddle. All right, so I want to end this video by looking at one more example. So this last example is just a real-world example of level curves. So I could have something like a temperature map of the US, so I'll call it T of x comma y, and my variables here, x and y, x represents the latitude, and y might represent the longitude. So this is something that a meteorologist, for example, may deal with. And I can see some of these level curves kind of drawn in this picture. So level curves are something that we deal with in the real world. Temperature especially, is something where it's great for multivariable functions and level curves like this to visualize what's going on in different regions. So for example, everywhere on this curve, I don't know if you can see it as I trace along it, everywhere on this curve corresponds to a temperature of 70 degrees Fahrenheit. And everywhere on this curve corresponds to a temperature of 80. So everywhere between where 80 is and where 85 is, so everywhere like in this region, and this region, this region, this region, is something between 80 and 85 degrees. So in terms of our goals, we have finished our second goal, which is using level curves to visualize functions of two variables. In the next video, we'll talk about finding the domain and range of multivariable functions.